Hello, my name is Victoria and I'm a country manager at Servercore. In this video, I will help you learn more about Servercore products. My colleague Ivan, our CTO, will give you a tour of our cloud platform and demonstrate how our services operate and talk about what it's like to work with Servercore's products. First, we would like to tell you about our data centers. Currently, Servercore has 4 availability zones in 3 regions with local presence in Nairobi, Almaty and Tashkent. Each Servercore data center is equipped with backup and support systems. Ivan will provide you more details about the presence regions, availability zones, and the cloud infrastructure in them. I'll now hand it over to him.
Hi, my name is Ivan. I work for Servercore. I'm happy to welcome you on our product demo. What cloud generally is a highly distributed, geographically distributed IT system. That notion, region, in cloud has specific meaning. It's a so-called fault domain. Multiple fault domains means that they do not break together almost never. So in Servercore Cloud for now, there are 3 geographical regions. It's Almaty in Kazakhstan, Tashkent in Uzbekistan, and Nairobi in Kenya. Those regions are separate sets of hardware launched in a data center with the software which runs on top of them. Fault domains means that those software sets work independently of each other. But cloud means that you use all those sets of hardware and software through the same one control panel, paying services in the same the same account with one payment method, and contact technical support or your sales representative via one channel of communication you prefer. So for now, we have 3 geographical regions. For the next year, we plan to extend our presence in each of them, and also to launch a couple of more regions, one in the European side of the continent and one in Asia. Now let's dive a bit deeper on the level of one region and look what it itself consists of, how things work. As I mentioned today, cloud region on a product level is a different set of APIs and sections in a control panel, which provides you, customer, with ability to launch and control virtual machines, or for instance, configure Kubernetes and manage databases clusters, or even work with bare metal solutions like dedicated servers and dedicated networks for them. All these functionality works independently of from other regions, some possible problems in them, which gives you an ability to build a resilient system. From architectural point of view, on the so-called backhand, each region consists of one or many availability zones. Here on this picture, Geo region Tashkent is shown. It is now in the middle of its development. It has not one availability zone as we have in Nairobi, but already 2 availability zones. When it will mature, it will have an extra. We think it will be 3 availability zones. But for now, 2 is enough. Enough for us, enough for our customers, enough for building stable and fault-tolerant systems on top of the resources. I will talk a bit more in details about availability zones later, but for now, just picture the system in whole. Each region consists of multiple availability zones. They are separate from each other. They can be connected with networks, routed networks, which is already controlled via a control panel. So, as I mentioned, availability zones appears when we develop our region, when customer needs rules or launch more complex systems. And when we do so, we take into account some local regulations. For instance, when we made a decision to launch another availability zone in Tashkent, we did that in a way that will empower our customers who launch financial systems software to do that in compliance with local regulations, saying that if you a financial organization, you have to pick locations for your systems with at least 5 kilometers between them. It's not an easy requirement to comply with, and we greatly helped our customers to solve this problem, being able to control all the infrastructure they launch via one control panel, one set of APIs, which is really great. So now let's dive one level deeper and see what availability zone basically is, how things work on this level. So each availability zone is one of multiple data centers located close to each other. This topology, one data center or multiple, is not visible for our customers. They work with availability zone or with a pool, which is a subset of hardware inside of an availability zone. So this topology is kept on our side. But when we choose data centers to host an availability zone, we pick those who comply with our requirements. What these requirements are. So basically, there are 3 sets of requirements which has a top priority for us. Number 1 is electricity. So connection to power sources. We always pick data centers which has at least 2 connections to power lines, to electricity production lines. And each line should also be connected to a power generator and a set of accumulators. This setup is really important because it allows you to keep the servers running inside in your racks 24 hours, 7 days a week, with no service disruption, no matter what happens with those power lines. And our experience shows that unfortunately, we use those systems at least a couple of times per year. So the worlds surrounding data centers tend to be not too stable. The next big part of requirements is internet connection. So data center is all about hosting servers for applications, for consuming and processing internet traffic, right? We strive to connect our availability zones to as much uplinks possible. Here, as an example, broad availability zone Unicom in Tashkent, in Uzbekistan. It has 3 lines of internet plugged in. In Kenya, we have the same. 3 different providers, and network equipment we use and software we wrote on top of it is able to switch traffic between the uplinks if something bad happens with those connection lines. It also is able to balance traffic between those uplinks, providing you with higher speeds and more throughput. When this traffic passes through border gateways, it goes through DDoS protection. It's a custom-built solution, which allows us to filter almost 98% of all attacks on level 3, level 4. So your servers, virtual or physical, will receive more clear traffic, and you won't need to tune them to mitigate some possible attacks. So first two sets of requirements were about connection to external sources of something, electricity or networks, and the third number of requirements is about quality of the data center, quality of its processes, and formal requirements, which allows us and you as our customers to build um, systems which have to be compliant with formal regulations. So what those certifications are about, it's, for instance, Uptime Institute certification. We always strive to choose the best data center possible. For instance, here in Tashkent, we have tier 3, tier 2 plus plus data center. In Kenya, we have tier 3 data center, which means that the data center design is of very high quality with redundant power supplies built nice for the technicians to be able to smoothly uh, serve the equipment which is held inside the data center and so on. These data centers are also compliant with ISO standard, showing high quality of processes, and PCI DSS, which means that there won't be any problems if you process some financial data inside them. In all those compliance systems, it's important to remember that if you need to process your customers' credit card data, your system should be compliant, your cloud provider should be compliant, and your cloud should use data center that compliant as well. So it's like a pyramid, and on each layer of this pyramid, everything should be done nice. At Servercore, we have you covered. Don't worry if you need anything like that now, or we'll probably will need something like that in the future. Start using our services today and be ready for that future. Now, let's dive one level deeper. On this picture, you see we have a number of pools pictured. On the left, there is a pool, UZ1. It's a pool for virtual resources in Uzbekistan. On the right side, you see pool TIS1. It's a pool, again, in Uzbekistan, but for bare-metal resources. Now we'll dive deeper in virtual pool architecture and qualities. Then we'll have a demo, and then we'll get back to that bare-metal pool and its services. So you might have noticed that on each slide I show, we basically repeat the same architecture in terms of disaster stability again and again. So here on the level of one pool, we again have redundant power supply, fault tolerant network, and data storage that lives through major disruptions. How is that possible? What pool basically is? It's a number of racks in a data center. Typically, this amount is not less than 4 racks. At maximum, it can stretch to 100 or even more. In each rack, we have a top of the rack switch. It is pictured here. And those top of the rack switches work together in pairs, meaning that servers that are located in those racks are connected to multiple top of the rack switches at once. Those services also have redundant power supplies in them, which makes them which makes it possible for us to connect them to multiple power sources at once. So here, if we pick any compute host here, by the way, compute is the host which launches your virtual machine when you ask cloud to do that in a control panel. Each compute host has at least 2 network cards, which allows us to connect it to multiple top of the rack switches. It has 2 power supplies, connected to different lines, and it has broadband network connectivity to network storage and backups cluster, which is located here at the bottom of the picture. This topology allows us to not only go through disruptions like electricity loss in a rack, but also to reduce the amount of times we bother you saying, sorry, dear customer, we'll have to turn off your servers because we need some maintenance to be done. When we have infrastructure with duplicated roles, we are able to perform security upgrades, some tuning, not disrupting your services. We just take care of one power supply, replacing switches to new models or adding some monitoring for that. Switch compute nodes between one power source to another, proceeding with another input. And at the end of the works, you as a customer haven't noticed anything, but we as a provider have, for instance, in this example, more flexibility, more clarity in metrics of our infrastructure.